So I was asked to talk about long-term non-progressors, which is actually a term I've not used recently, and I'll get into that in a second. But that made me think about, well, where did this come from? And it turns out that this whole concept of long-term non-progression, that is, people who have HIV, untreated HIV, and do not progress, um, I actually thought it came from Tony Fauci and Jeppy Pantaleo, but actually it was earlier than that. There was a study that was published in Journal of Infectious Disease. Susan Buckbinder, who most of us know, and others, using a cohort, presumably back in the late 1980s, identified 24 men who maintained a CD4 count over 500 for 5 years. We weren't doing viral load testing back then. It was very experimental, the assays weren't that sensitive, but only one person could have detectable virus. And so that concept that was introduced in 1991 really focused on people who did not progress clinically, either people who did not develop HIV or AIDS, or people who did not develop a CD4 decline over time. And it became a really important area of investigation. One of the more dominant themes in that decade, in the 1990s. We started doing some work in that area. We had all hoped from the get-go that it would lead to better insights into how we might cure HIV. Now, that was 1991. That was 35 years ago. Things have changed. Right now, when we study this phenomenon of non-progression, we're really not focused anymore on the rate at which people lose CD4s, or the rate at which people progress to AIDS, or it's all about controlling the virus, right? And so the terminology that we typically use now is controllers, right? Elite controllers, post-treatment controllers, and so forth. Somewhat of a similar phenomenon. But it really bases on the fact that at the end of the day, if we don't want people to progress, either in terms of losing CD4 or developing AIDS, got to get the virus under control. And so now the focus is on this concept of control, virus control. And that's typically either done longitudinally, but often just at a given point in time. All right. Now, over the past 3 decades, there have been sort of 4 different clinical scenarios that we focused on. They're somewhat distinct. First, there's the long-term non-progressors, and in the mid-1990s, when we began to measure viral load, we realized that most of these long-term non-progressors had undetectable viral loads. And so the terminology, and I don't know where it came from, I'm pretty sure it came from Harvard. They blame us, but the terminology is basically, it just stuck. We call these individuals elite controllers, right? And these are people who maintain viral loads below the level quantification forever. Or, for months.
Definitely Harvard. I was there when they did it, when they coined it, and we advised them against it, and they did it anyway.
All right. Well, it's an unfortunate terminology, but we do blame Harvard.
And for what it's worth, Loreen does not like it either.
We're stuck with it. All right. And then the next story that came around, and this was interesting. This was actually, maybe 10 years ago now. The French, led by Agir here and others, began to talk about individuals who go on antiretroviral therapy, stop drugs, and don't rebound. And they called them the Visconti cohort. They called them the post-treatment controllers. This study got no respect, particularly in the United States. They had the toughest time publishing this article. Most people said, oh, you guys are making this up. These are just elite controllers who went on treatment, stopped treatment, nothing new here. Trust me, I was involved with these debates. Our friends in France were really annoyed by all this and thought it was basically just, the usual type of Americans looking down upon the European science. It was quite a debate. They put this paper through 10 different areas, 10 different journals, could not get it published. And I was sort of involved trying to sort of do my best because I thought this was one of the most interesting studies that came out during that era. Finally got published in PLOS Pathogens, and it blew up the world. It became one of the most cited papers in HIV, and it has really dominated a lot of discussion in HIV cure since. And then an American group led by John Lee came along and basically developed the CHAMP cohort, which confirmed the whole thing. So now we all believe post-treatment control is a real thing. These are people who were progressing, These are people who had high viral loads who would not have done well, who went on antiretroviral therapies, who stopped drugs, and all of a sudden are controlling the virus. Mechanism to be discussed. Then we jump to 2022. All right. And this is where Loreen's story comes in. And I'm going to get to it in a few slides. But Shu Yu and others began to focus in on people that they termed exceptional controllers, right? So these are the exceptional, initially it was exceptional elite controllers, but now we just call them exceptional. These are individuals with extremely low viral loads, extremely low reservoirs, and may in fact be cured. Rare, and we'll get to that in a second. And now we're in the modern era, where I think every time we turn around, we're hearing about 2 or 3 more cases of people who got some crazy intervention, vaccines, immunotherapy, this or that, who stopped therapy and now controlling it. So we probably have on the order, I'm guessing, across all the studies, at least 50, maybe, solid individuals who've been well described, who had bad HIV disease, who got an intervention, and who controlled. All right, and so these are the 4 different groups, and I'll talk briefly about each. But let me just, before I go there, get back to this issue of long-term non-progression. There is this phenomenon that has also received a fair amount of attention called viremic non-progressors, VNPs. And these are individuals that I think are extremely rare. And I'm not entirely sure that they totally exist. And there's been some debate about this. But these are individuals who have high viral loads, but yet do not lose CD4 counts over time. Okay. And this became kind of a big thing about 10 years ago. We don't really study this anymore because no one lets anyone with a high viral load stay with a high viral load, no matter what their CD4 counts are doing. So everybody gets treated now. But at the time when we thought antiretroviral drugs were pretty toxic, we didn't want to give therapy. Those people who had high viral loads, but their CD4s remained stable and high, the so-called viremic non-progressors, was a thing. And it was really interesting because it looked like the natural host of SIV, right? African monkeys, pseudomagabes, they also have this phenomenon where they get infected with SIV, cousin of HIV, and have extremely high viral loads, but never get sick. And the whole idea was that the natural host and the retrovirus evolved over time, so both were happy, and perhaps that would have happened in people, over centuries, who knows. But in both the monkey model and in the cohorts, seems to be associated with low CCR5 expression, low amount of inflammation, and so forth. But again, we don't really think about this anymore because no matter what a person's viral load is, they get treated. All right. Now, back to the controllers. Natural controllers, elite controllers, whatever you want to call them. These are people, it happens that about 1 out of 100 men will achieve this state in the North. We don't really know much about the South. But we do know very clearly from study after study that women are about twice as likely to achieve elite control as men. And we haven't quite figured this out, the mechanism. We have people who've been elite controllers going back to the 1980s. So that's 40 years. Once people maintain it for a few years, they tend not to progress. Some people who are quote unquote elite controllers, virus undetectable for years and years, some will progress, but it's pretty rare. They generally basically do well. When you look carefully under the hood, for the most part, long-term controllers are doing well clinically. But if you measure any measure of inflammation, typically is a bit higher in people who are elite controllers compared to people on treatment. There was some data cross-sectional suggesting that they have more heart disease than they should. And as a consequence of that, the US guidelines and other guidelines recommended that people at least think about going on treatment, even if their virus was still undetectable. That sort of became standard here in the United States, less so elsewhere. And it's the whole idea that rather having the immune system work so hard to keep the virus under control with all the collateral damage from the inflammation, well, let's put them on treatment. But then people go on treatment and then they have issues with treatment toxicity or stigma from the drugs. They want to go back and forth. So we don't really know to this day how we should actually manage people who are elite controllers. And typically, when I see patients in this situation, I sort of suggest that they go on therapy, go over the pros and cons. I say, at the end of the day, if you go on the meds, they don't cause any problems. That's probably the best thing to do. Um, but it's a mutual decision. Anyway, but the thing that we study these guys for and women is mainly to figure out the mechanism. And there have been, I bet there are hundreds and hundreds of papers about the mechanisms of elite control. Um, and 90% of them focus on CD8 T cells, right? CD8 T cells, right? You may remember CD4 T cells are involved in sort of coordinate the immune system. But at the end of the day, on the front lines, where the virus is, the CD8 T cells are the cells that are involved in killing the virus. And CD8 T cells from elite controllers, there are a lot of them that are HIV specific. They have the capacity to proliferate when they bump into the virus. They have the capacity to control the virus through cytokines. They have the capacity to kill the virus directly by releasing these poisonous enzymes, and so forth. And there are multiple different pathways associated with why good CD8 T cells do what they do in this setting. There is now data coming out that it may not just be CD8 T cells. The CD4s are important. Interferons are playing a role, autologous antibodies. It's almost certainly a complex networks responding. But without a doubt, at the end of the day, most of the work is CD8 T cells. And we know this from the monkey model. Monkeys who control a virus, if you go in and just take out the CD8 T cells in the monkey model, the virus rebounds. And we see this in people. If they get chemotherapy or, for cancer or for a transplant, sometimes, not always, their virus will rebound. And typically associated with loss of CD8 T cells. And when they come back, the virus goes down. Anyway, that's the mechanism of the elite controllers. And we'll come back to that shortly, what we're doing with that information. But then let's go to the next story, which, came out a couple years ago. And this is the issue of exceptional controllers or natural controllers. This was, a number of groups were talking about something similar, but then there was this really high profile paper in Nature by Shu Yu at the Raygon, in which they collected a bunch of elite controllers and looked at the amount of HIV DNA, the size of the reservoir in elite controllers compared to individuals on treatment. And as you can see here in green, this is basically the size of the reservoir. This is a log scale. And people on treatment typically have between 1 and 10 infected cells per million PBMCs. Elite controllers, a lot of them have pretty high reservoirs, but many of them have low reservoirs. And occasionally you see these people down here who have extremely low reservoir sizes. Well below, 10, 1,000, 10,000 times lower than what you typically would see. And this led to this issue is, well, what's going on with these rare individuals that were called exceptional controllers? And in fact, I believe this is Loreen here. This open dot means that actually this was the lowest level that we could quantify theoretically, given the amount of cells that were available, but we couldn't find any virus. This led to the concept that really has been fascinating about whether or not some of these elite controllers, exception controllers, essentially got rid of their entire virus reservoir back in the day. And this gets to Loreen's story, probably the single most fascinating story, I think, in the business. Loreen acquired HIV back in the 1980s, I believe. Never got treated. And in 1996, when we started doing viral load testing, her virus was undetectable. Okay, so she's an elite controller. She's a woman. It's not that uncommon. But then she maintained this status of having an undetectable viral load for decades. There's been a couple of blips, as I recall. Okay, so she's super elite controller. She's an exceptional controller. Um, but then we noticed that her antibody levels were waning, and that's extremely unusual. Usually once you have an antibody response, it's pretty stable. And then she started participating in studies at NIH. She went out and hung out with Stephen McGillis and Mark Connors. They had trouble finding virus. They published a paper in Blood about this. She was coming to San Francisco. We were sending blood elsewhere. She went to the Raygon and met up with Bruce Walker's team. Um, and the entire field became fascinating to see what's going on with Loreen. And in 2022, Shu Yu's team basically compared to everyone else and said, this is the first individual that we can confidently say has no virus that can be detected, even in 1 billion cells, which is remarkable. Timothy Ray Brown, the Berlin patient, we could find virus. It was it was not necessarily fully intact, but we could find more virus lying out around in Timothy cells than we could in Loreen cell. And so we basically began to think, well, did she cure herself? And why would that be? Right. And then the second patient came along, the Esperanza patient. This is a woman also who was identified in Argentina and had basically kind of a similar story. And the big question becomes, well, what? What is so special? What did they do that no one else, HIV has been in 70 million people over the decades. We are not aware of anyone else having achieved this. And there's been a fair amount of work. I mean, Loreen has been very heroic, bouncing around the world, giving her tissues, giving lymph nodes, giving gut. And I think the most compelling story here that is still being worked out, and we're going to hear an update about this at CROI with regard to Loreen, otherwise known as San Francisco patient. I dubbed that because I was jealous that every other city had a patient. So we stole Loreen from Davis in Sacramento. Anyway, Loreen has these, and she's going to talk in a sec. Loreen, get ready. So Loreen has, when you look for HIV-specific CD8 T cells in Loreen, you really can't find them. And that's not too surprising because she doesn't have any virus, so those cells don't hang around. But when you do find them, they are extremely potent, and they are able to attack the vulnerable parts of the virus, and they have this capacity, and this is very important, we'll come back to it over and over again, they have the capacity to proliferate, to expand when they bump into HIV. And there's also some other hints coming in that they have some special properties that is going to be presented by the Raygon team. And I want to connect Loreen with that team, but it's going to be presented as a late breaker at CROI next week. I'm going to stop for a sec. Loreen, are you there?
Absolutely. And, Steve, I got to tell you, when I met you 21 years ago, did we even have a clue
No.
that this would happen?
Mark Connors did, but not us.
I'll never forget it. I get this really brief email. I think you were at CROI a few years back, remember? And Bruce Walker made you my champion.
Yes.
Do you remember that?
I do. I do remember that.
No.
Yes.
Any and all things that Loreen has of interest, you're going to be the guy. And so this is amazing. So folks, I was deemed the San Francisco patient. And what happened was I begged Steve to please let me know if they would please use my real name in their presentations. So, everybody knows that you're a maverick, and now they're finding out that I am too. Mm-hmm. And so when she was in Rwanda, last summer in July, she's so kind. She's become a real supporter of me, of course, having studied my immune system for 21 years, because the Harvard study at Reagan was the very first one that I enrolled in. Did you know that?
No, I did not know that. I thought it was NIH.
2004 Halloween. Yeah. And then 2 years later, it became the LTMP study at the NIH. And unfortunately, during the COVID lockdown, I would have made my 17th annual trek to donate lymphocytes to their study in lockdown. And so they retired me, right? 17 years, right?
Yeah.
So 1992, July, this year will mark 34 years. 34 years. I'm happy that our lovely anonymous Esperanza patient in Argentina, I believe, the
Yes.
young mother, diagnosed 2013, folks, 2013, very similar to mine. And by the way, she used slide that you included, which she invited me to include a disclosure to the world that I did happen to be on a cancer journey. Why? I was really wanting to put that out there because I promote the thing about my destiny seems to be to give people hope that HIV cure is coming down the pike. And then number two, I just said wonders abound in science. It moves very slowly, the wheel, and that soon there will be a cure for cancer as well. And that's why you see that embedded little video that she included in her PowerPoint slide set. But this is the generosity of their heart. And then back in '08, you know Dr. Barbara Shacklet, right?
Of course. Yes.
UC Davis. And
Right.
I joined her gut study. Gosh, I think that was 2008, somewhere in there, 2006. Her paper, I think, was Mendoza et al. I can't remember the
She had a couple
journal.
papers. Yes.
Yeah, well, and she's the one that discovered no detectable virus, which is why I'm going to tell you on that PowerPoint slide of Shu Yu's
Yeah.
that the lowest, there's a gentleman somewhere who's very similar in my case. And so mine, if you look at that slide, hon, I believe she said that I'm either right below him or right above him at the lowest range on that. What? I forget.
Oh,
Is
I
it
thought you were the open circle, but okay. You're probably right. Sure.
well, could have been, I do have brain cancer, so hello. But this is my history. And obviously here I think I must mention the creation of my Zephyr Foundation, my nonprofit, to represent HIV controllers around the world.
Right.
That website's dark now because we did do, I think, like 4 dozen referrals. Because there's did you know that there's 22 different cohorts around the world that study us?
No, I did not know
That's
that, but I'm not surprised.
that's Zephyr Foundation archival spreadsheet. Yeah, because I used to track them. Why? Because my visionary behind the Zephyr Foundation website when we launched, like 2008, he firewalled and encrypted a forum. I moderated. Zephyr was my undisclosed name, right? My avatar on a
Uh-huh.
worldwide website. So that's the history. So 34 years this July, and you might want to confirm with Shu. So that's just a
Lorene,
couple of
tell us how you
interesting
feel. Tell us how
vignettes.
it made you feel when you
Well,
learned
very
you could
humbled
benefit
for one
yourself.
thing. I mean, I'm in the world of science fiction here. No, the fact that she presented because and you called me, Steve, or you emailed me and you said, you're kind of a brand name, Loreen. You're kind of like Oprah. Everybody, I hear everybody saying Loreen, which is fine. But ultimately, Linda, honey, I was very humbled because I realized soon after that this indeed could be, when they define, which is the Holy Grail here, the mechanism at work. I always told them, if there's one of me, there's got to be more. And wouldn't it be wonderful to reverse engineer this immune system for a vaccine or a treatment? Or so humbled, totally humbled by all of it. What I did do though, early on because she suggested this last year, that chemotherapy infusions, and Steve, you agreed with her that chemotherapy infusions, of which I had immunotherapy for 15 weeks with Keytruda, the drug that extended Jimmy Carter's life. I had that for 15 weeks. Small bags, I think they were 200 ml. But anyway, so 15 weeks, 2023 with that. And then I did 21 weeks with a Keytruda, with a booster to the Keytruda for 21 weeks. And that was called carboplatin, which was, originally developed to be a cancer drug. And so that lasted, but my lung oncologist was not really impressed with the, when he assessed it through a PET scan. He prescribed actually for 10 months until it developed resistance to, I'm forgetting the name of it. 10 months, the cancer virus itself, they did specialty genetic screening at no cost to me. And they discovered that the cancer cell had developed a resistance to that drug after 10 months. And so now, because of the many, I had, we were scheduled to do a radiation treatment over there of the brain, but we were only doing a targeted application to about 3 seedling tumors in the upper right quadrant of the brain. And we did a PET scan, and it indicated that there were 20 or 30 seedling tumors that cropped up in a month. So that means that, not having any treatment because this mutation occurred at 10 months and counting on this pill. It was a state-of-the-art chemotherapy pill. I could take it home twice a day. And so he pivoted. And so last Tuesday, I'm so happy to tell you that I successfully completed 10 whole brain radiation treatments, very short. Saw like bright light, a little bit of warmth at the nape of the neck, whole brain radiation treatments, 10 in a row. And they let me ring the bell. They have a brass bell. I always thought and heard that when you're in a remission that you ring the bell. But no, it's such a grueling challenge to go through that and complete it that they let you ring the bell, and it's sponsored by the union, of the RNs, and they video me, and I don't know where that goes. And so he will assess with a PET, no, actually it's an MRI on April 6th. We'll get an update and see how we've done.
Loreen, can I ask Steve a question?
Yeah.
Steve, so what does this tell you? Now, let me ask you. Now, I know that you've told me about people that should, even, in other words, if they've had a history of cancer, which Loreen does not, I mean, before this, should they should stay on their antivirals. Now, so we have Timothy Ray Brown, who was cured, but his cancer came back, and we have Loreen now, who has cancer. Does this mean to you that maybe people should be on therapy no matter what? That's one question. Or and I guess this is kind of part of the same package. So her immune system is controlling HIV, but does that mean it's also unable to fight other things like cancer? Does those two things occur to me? What do you think?
Very provocative questions. Very provocative.
Very.
With Timothy Ray Brown, right? He had the Berlin patient, right? He had leukemia, I think, on lymphoma. I'm not, actually, I think it's leukemia, back around 2005 or so, and got all this chemotherapy, and it was a rough course. I mean, he was on multiple, those individuals, if they don't have HIV, are at high risk for future cancers. And so what happened with Timothy, I think, was expected from the malignancy. I can't imagine his HIV had any impact because there just wasn't anything there. I mean, there were remnants, but and the same with Loreen, I got to say. So a typical elite controller um, who clearly has virus develops cancer, I would jump all over that with treatment for sure. And anyone who has potential high levels of inflammation that might lead down that road, I would strongly encourage it. But again, with Loreen, we know that she doesn't have that chronic inflammatory state, and she doesn't have any virus to treat that we can find. So I didn't think in my mind that she should go on treatment and didn't push for it, and I don't think anyone else did. So the answer is, I think your run-of-the-mill typical elite controller should definitely go on therapy in this setting. Timothy Ray Brown and Loreen, it could go either way, but I probably wouldn't have pushed it too hard. Let me, Loreen and Linda, let me finish
Right.
I'm getting now behind. Let me do my,
Okay, go ahead.
Jules, I think Jules, I know you were asking about this as well. Do you want to jump in here real quick?
Yeah, I did. I just put it in a personal chat to you. I didn't want to raise it, but somebody did raise it. And so and it's similar to what you were talking about. Um, with everything that Lorraine's been through with her immune system, which we don't completely understand, but it seems as though, her immune system seems to have gone through some changes having been exposed to HIV
Right.
that have created some sort of effect on the immune system that may have encouraged the development of cancer.
I would be, if Lorena developed a lymphoma, leukemia, KS, HPV, anything that's classically related to HIV infection, I would be more concerned. But the cancer she has never been associated. It does not. We don't see this at an increased rate in people with HIV versus not. So I doubt it. I doubt it. And then when we look at our immune system, it's basically otherwise pretty normal.
That's
But
encouraging.
let me
Go ahead, you
let's
finish up,
circle
Steve.
back. Let me finish my talk real quick. But these are questions they're forcing me to think about things I've not thought about before. Thank you. All right. Post-treatment, I'm going to run through the rest of this pretty quickly. The next group are the post-treatment controllers. Here's a really
Steve,
nice,
may I
yes.
interrupt for a moment?
Uh-huh.
I've got a representative of my organ donation
Okay.
that's waiting for me, honey. I really have to go. I'm so sorry. But
All right.
the last gift project in San Diego, now I'm participating in that. If you folks don't know about it, look it up. It's UC San Diego. It's called the Last Gift Project, whereby I have signed their documents and enrolled under special exemption by their IRB to donate any organs to HIV cure research in their network. And who's sitting out there talking to my older sister from Los Angeles, who leaves today at 1 by air, is Ninja, representative of that autopsy recovery team. And so I must leave, but thank you so much. It's so interesting. I'm so happy to be with all of you today, and God bless all of you. Yeah. So
All right,
I'll leave
Larry.
you, and all things positive frequency. Yes. And thank you, dear,
Yes.
for always being my champion. Yeah. Thank you.
Thank you, Loreen, for
Okay.
jumping right in and helping us again, as usual.
Always, anytime. All right. Bye-bye.
Bye,
Love
Lorraine.
you.
Love you too.
Yeah, the last gift. What a heroic thing for her to be doing. And Jeff Taylor, I think, just put something. Jeff's deeply involved in the last gift. It's an amazing
Hi, Jeff.
program down at UC San Diego. All right, let me get back to my. So now I go back to my boring talk after that discussion. I'll try to keep it interesting. All right. Again, Post-treatment controllers. All right, here is, I like these types of figures, but they're probably uninterpretable most. But anyway, this is like, I don't know, hundreds, a few hundred people stop therapy, viral load goes up for the most part. This is typically what happens, and people start therapy late versus
Steve, you're
people who
you're
don't.
not sharing your slides.
Oh, that's what's going on. Yeah, I stopped. Sorry.
It's okay.
Jeff, can you finish? Michael, are you still on the call?
I'm here. That's why I
Can you
just.
fix that? Okay, great. Thank you.
Got it. All right. Anyway, so here's the figure I was talking about. Bottom line is, right, we all know this, that, when people stop therapy, these are 382 people, 90 some percent rebound. They go up to around 100,000 and they stay there. It's a little bit lower if you start therapy early versus late. But occasionally people don't rebound and stay low, but it's pretty rare. In this study, only about 6% of people who started therapy early were able to keep their virus below 50 for about 3 months. So low numbers, but it does happen. All right. And these people are people who we don't think, they don't have HLA-B57, they had high viral loads before. We don't think they would have done this without treatment. So this is the post-treatment controller phenomenon. It now exists. The question that always comes up is who is likely to become a post-treatment controller? And it turns out that this is like the Goldilocks thing. If you start therapy like really early, like in the first few weeks, and you stop therapy, virus rebounds. And if you start therapy very late, like after month 6, it rebounds. There's like a sweet spot around like 2 months. If you were off therapy for a couple months, and we're not advising people to do this at all, but if that's about the time, if you acquire HIV and you don't get treated for a few weeks to a couple months, there's that kind of window. That's when we think that the immune system is being primed by the virus, but not being destroyed by the virus. And those are the individuals who, when they stop therapy, they don't rebound. And so we're trying to figure out more about this. I think the French have a study at Croy where they're going to be able to say, okay, you started therapy early, you can stop safely, and the other people can't. So let's see how that plays out. But a really interesting phenomenon that we're really beginning to think a lot about popped up in this old study by Sarah Fiedler, John Frater at the UK, um, where they looked at called Spartak. And this was a study of people in the UK cohorts and I think also in Northern Europe and in Africa who were randomized to either get no treatment or to get a brief period of treatment. All right, this is what we're doing. This is probably 15 years ago. And then the group who got a brief period of treatment, they stopped therapy, most rebounded, but some did not. Turns out that if you were a Black woman living in Africa, your risk of not rebounding was much, much higher than if you were a white man living in Europe. And it was a dramatic effect, and we didn't know if it was the environment, Africa versus Europe, if it was race, or if it's sex. It's almost certainly sex, biologic sex, that females, just like they're more likely to be elite controllers, are more likely to have post-treatment control. And it's very important in the cure agenda because now we're doing these treatment interruption studies in Africa, and most of the participants often are women. And we're seeing a lot of people who don't rebound, like in the fresh cohort. And we don't really know, in San Francisco, we know very precisely among, older men, the rate at which they will rebound. We know that in most of the North, but we don't really know that much about women at all. And we don't know much about what's happening in Africans at all either. And so, but this is a pretty consistent trend across other studies, and important for the cure agenda. All right. Post-interventional controllers, this is what we all talk about these days. I'm not going to go into any detail. This is this concept that you take people who, when they stop therapy, they look like this. You give them immunotherapy, they look like this. Okay? And is another way of looking at it. And this whole idea that you build up the immune system to control the virus based on what we've learned from the post-treatment controllers and the elite controllers and the exceptional controllers to keep the virus low. We need two things. We need a low viral load, low reservoir, and a strong CD8 T cell response. And that's led to this concept of reduce the reservoir and control. And multiple approaches are being taken. You take people on long-term therapy. Here they are on ART. You give them a bunch of immunotherapy, vaccines, antibodies, cytokines, adjuvants, so forth. Various different cocktails that induce your CD8 T cells, your CD4 T cells, and so forth. That's the goal. All right. Let me just show one study, the study that we did. This is a so-called kitchen sink study, 10 people. We took a group of 10 people during COVID, gave them a vaccine, gave them some broadly neutralizing antibodies. The concept is that when the virus rebounded under broadly neutralizing antibodies, that it would turn on T cells. We could talk about it if you want, and so forth. Anyway, they got this cocktail of immunotherapies. They stopped therapy. 3 people rebounded like they should. Boom, boom, boom. And 7 did not. Now, the reason I'm showing this is that I just want people to start thinking about this is kind of like the new normal in these immunotherapy studies, that in a subset, 20, 30, 40% who get immunotherapy, stop therapy, they do this, right? The virus rebounds. Some people don't rebound at all, and we had one individual that didn't rebound. But usually people rebound. The virus goes up slowly, stops at a low level, this is 1,000, and bounces around, right? And as we see this over and over and over again. And again, the majority of people rebound typically in most studies. But when we see this, so we see this all the time now in all these studies, that a subset are doing this slow rebound, low peak, bouncing around. Now, all these guys had to go on therapy because of COVID stuff. They either got COVID or they needed to get the COVID vaccine, back in the day. So we don't know how long this would have lasted. And so we're trying, and it's not just us, right? I mean, multiple groups, including the Rio team and the Fresh team that we heard about, Croy, similar outcomes, same dynamics. Why? All right. Now, probably the most important slide. All right. This is the mechanism that we have seen in these studies. And now we're seeing it in the post-treatment controllers, and we always saw it in the elite controllers. That is, that for whatever reason, people are developing these very powerful CD8 cells that target specific areas of the virus that are very conserved, vulnerable to the immune system. And most importantly, when they see the virus, they can expand dramatically, right? And Rachel Ruteschauser, whose team led the efforts in our study to figure this out, refers this to as a, the pouncing cat, right? So the CD8 cells, we saw this in Loreen, we've seen this in these people, that the CD8 cells are just very quiet, sitting there. You can't find them. But boom, when the virus comes, they pounce, they kill, then they go back to rest. And that's the most consistent marker of control. Which brings me to my last point. All right, and then I'm done. And this is my own personal opinion, that we have got to stop studying. We should continue to study controllers, of course, but it can't just be about writing papers, right? The field needs to shift toward developing therapies. Otherwise, we're wasting our time. And I don't think we're doing this very well as a field. The vaccine field does it great, right? They get an idea, they make a product, and they test it. We're not doing that. Um, and I think that we should. And a very promising area to go about this is to see if we can actually take this knowledge that's being gained by the controllers and make a treatment, a cure. All right. And I think the only way we're going to do this is to be logically thinking about how to take the findings from these controllers and engineer T cells. All right. Because it's really not going to be easy to do this with vaccines and immunotherapy. You saw people stick around 1,000. That's great, but that's not good enough. And so based on our work across all these controllers, we now have a pretty consistent model for how this should work, right? And we should be able now to engineer the immune system to do this, right? And we can begin to do this logically, leveraging this massive investment that's happening across all of biomedicine to do this. So there's a lot of knowledge being gained. Rachel had this really beautiful paper just published in which she argued, how we can start doing this. And this is sort of the kind of the focus of our team right now is to work, NIH Gates. The Gates Foundation is really invested in this idea to begin to try to make T cells do in everybody what they do in people like Loreen. Anyway, that's my vision for how we're going to get to a cure. All right. In conclusion, there are multiple clinical scenarios in which HIV is controlled. We have these 4 unique groups. There's very similar mechanisms across all 4. You need a low reservoir, and you need these CD8 cells that can proliferate, that have stem cell-like activity. Other pathways are becoming more important. There's a lot of data suggesting NK cells are also playing, autologous antibodies. That may be true for some. I'm not sure it's true for all, but we have to figure that out. And it's likely that in order to get a good remission in the cure study, we're going to have to get that reservoir low, or should be low because they start therapy early. And we need that strong immune system. It's going to have to be there at the get-go, because I didn't show this, is that we think in order to achieve these outcomes, the immune system has to be responding from day one. Once that virus begins to rebound, if the virus doesn't jump on top of that, if the immune system isn't on top of that virus from the day one, the virus wins and you never catch up. And that's my talk. And I'll turn it back to Michael and Linda. Thank you.
That's great, Steve. Derek, did you have any questions?
I actually put a number of questions in the chat box.
And Derek, you're going to need to speak them because I lost the chat when I got disconnected.
Arg!
I can
Okay.
do that.
I found them if you want me, but Derek,
Alright.
go ahead with your questions, and then if you miss any,
and
I'll.
then you can do that too, Jeff. You can
Yeah.
encapsulate them and, shoot them to Steve after Derek is finished.
Certainly. I'm trying to find even the first one now. Sorry about that. And, I had made the first statement earlier in your talk. I just really thought about how both HIV and cancer are really tightly entwined with one another from the very beginning, both in like everything, the development of therapies, the medications, and the things that were happening for folks. Just it they they've been feeding off of each other in research for decades now, and I'm not. I wonder what your take on this is, and that is the idea that perhaps the tool or the process that we're looking for may already be in someone's cancer lab. Since both gene, we're just talking about gene therapy and
Right. Derek, so just people need to know this. This is a somewhat related thing. Cancer immunotherapy, CAR T cells, PD-1, the Jimmy Carter drug that Lorraine talked about.
whon.
If you trace back to where all that came from, it's HIV money. A lot of it, right? The HIV investment by Tony Fauci, everyone else in the 90s led to these discoveries and development of all this stuff. So the cancer field owes a huge debt to the HIV field. And more importantly, the taxpayers need to know that the investment in HIV has paid off massively outside of HIV.
Right.
And that's an important story that needs to be told. But it's going the other way now. A lot of cancer is a persistent cell that's a disease cell that's abnormal, that's throughout the body, that's hard to find, and we have to kill it. That's the same thing with the reservoir. Um, and um, and the advances that the cancer world is making in terms of gene editing, CAR T cells, PD-1 therapy, all these immunotherapies are being used in the context of HIV. The big problem, of course, is that people in cancer have an untreatable disease. People with HIV have a very treatable disease. And so what you can do in cancer, you can't do in people with HIV. And a lot of these drugs have toxicity. And so making that transfer has been challenging. But it's a two-way street.
Right.
But, yeah.
In 2014, there was a lot of talk about HIV becoming less virulent and what's happening with that less virulent HIV. However, I keep on thinking in terms of when we're talking about cancer, we're talking about body cells that go erratic. It's not necessarily the immune system; it's literally the body. And I'm
Right.
wondering if there are, if it's possible that even at not finding the HIV virus, or there might still be particles of HIV or something that still could be affecting the body that helps create the environment. I know they often talk about the body's biome and its effect on cancer development these days, and but create conditions that can form cancer,
Yes.
particularly when you're considering older adults and aging
Sure.
adults.
Absolutely. That definitely is well known. But people with HIV, there's chronic inflammation in tissues. The inflammation turns on when the immune system is inflamed. 90% what the immune system does is shut it down, right? Because you don't want the damage. When you have chronic inflammation and you turn on the immune system, you have this inflammation, then all the brakes in the immune system get turned down. And those brakes, when they come on to squash things down, prevent the cancer immune cells from working, and you get cancer. And so this is why we see an excess amount of certain types of cancers, even in people with HIV and on treatment. It's all a circular thing.
And
Okay.
the thing about cancer too is it's like that there's all these it's all this genetic involvement that is a whole different story, I think. I mean, I know Loreen very well. I know she was a smoker for a very long time. I know she started with lung cancer that metastasized to brain cancer. She may have gotten it anyway, even if
Right.
she had no HIV involvement. So, I mean, it's apples, oranges, bananas, and it's a whole so many different things here. I mean, it's about trying to make sense of it. So, is that
I
good for
think
you, Derek?
almost.
Okay, go
And,
ahead. Go ahead.
one of the things, and actually it came from Lauren when I met her years ago, um, when she was talking about controllers. Um, she often mentioned, even us as controller, there are other health concerns that we have to deal with often. And I wish she was still here, but I wanted to ask, like, so what are some of the more common health conditions for folks that are otherwise HIV controllers of any type? Or are there common health conditions?
The debated, there are some data published 10, 15 years ago that atherosclerosis, heart disease, more common in elite controllers than people on treatment and people that had HIV, maybe from the inflammation, which really led to the concept that people should get treated. But yeah, it really, Derek, all comes down to this issue of that the inflammatory state is a little bit elevated, and as a consequence, you can get aging, heart disease, these cancers. The risk is not dramatic; it's subtle, but it's consistent. Um, and I don't know if Richard Jeffries is on the call, but he has always been pushing very hard that when we go into these remission strategies that we're talking about, right, taking people off therapy, and keep making them essentially controllers, well, is that really an advance? Because now they have inflammation. And my response has always been, if you're taking your meds and you're doing fine and you don't care, stay on your meds, you're done. It's everyone else that needs a different strategy. And then you get the trade-offs between treatment toxicity and stigma and money and everything else. Anyway, but a good question.
How about a lower dose for those people of antiretrovirals?
Yeah, that's been proposed. No one has been brave enough to study it.
So I do have one other question for you, Steve, and it's something that didn't come up in our in-person meeting. I think folks were a little nervous about asking you, but I won't be. I heard from a number of folks in my community here that identify as long-term progressors. Many of them didn't start their medications until quite late in their HIV. A lot of it was on the insistence of their doctor. A lot around what you were talking about that still benefits you in X, Y, and Z sorts of way. And quite a number of them were meth users in their career. And many of them had talked about, and it's a very old myth about HIV, and that is meth actually helped their immune system to fight off HIV. Could you put some of that at rest or at least in context? Have you
I've seen
heard
data. I've
this?
California
seen,
question for you.
I've
Have
seen
you heard
data
this
that I've
before?
seen the relationship between, meth use and HIV control is complicated. Honestly, and we've seen evidence that it's not necessarily the worst thing in the world. So and we've never really talked about it because, you'll get killed and it's just, why go there? Yeah, no. One thing that pops up a lot, and I don't, is hepatitis C.
Mm,
In our studies, if you have hepatitis C, which is associated, with intravenous drug use, you are more likely to control. And we've always wondered if the hepatitis C was like an adjuvant that kept turning on the immune system to control HIV. Now you would never go out and get hepatitis C to control your HIV, but you're asking questions that we should have stopped in your first sentence. That people are nervous to ask this question. Let's move on.
Wasn't there another hepatitis type, hepatitis G or something that they thought was protective as well?
Oh God, I hadn't heard that, but I wouldn't be
yes.
surprised. The immune system's complicated. If you have a chronic if you have a chronic virus and you're constantly turning on the immune system, it causes harm in one part but benefit in the other. Like CMV. CMV does all this harm, but actually does all this benefit. CMV seems to protect against bad COVID, for example. So yeah. But it's always better just not to have any of these viruses and live in a bubble.
Okay, so Michael, do you want to
Simon
go through the
asked,
chat?
wanted to ask.
Oh, go ahead.
Okay, I wanted to ask: would people who started too early be able to stop in 2 stages? And it says first to generate the right immune response.
Uh, yeah, so a couple studies are doing this now. Um, and some have argued that this is in fact what happened in Rio, which Simon's very involved in. They stopped therapy, went back on therapy, and then stopped again and did well. Um, but yeah, it would make some sense if we ever figure out the dose of virus that is optimal to prime the immune system, right? And I think dose in terms of how much virus there is and how long it was there. Then yeah, if someone starts super early, then down the line they can do a brief interruption, prime the immune system appropriately, but don't destroy it. Theoretically, that would make some sense. Operationalizing that would be very difficult.
Yeah, thanks, Steve. I think a long time ago, back at the end of the 90s, there were some activists that were interested in pulse therapy in order to generate some level of immune response. And I don't think it didn't lead to anything back then, but it was the same sort of design that groups like Rio are looking at now.
Right. It did actually. There was always hints that it helped, but it was never dramatic.
Yeah, thanks.
I think Alistair had a question as well.
Okay, yes. Go ahead if you wanted to get Alistair to ask his.
Alistair, are you still there?
Did we lose you
Sorry
out?
about that. Another call came in from my brother in Scotland. But I can go back in the chat and find it. If you want to go on somebody else quickly while I go back in the chat.
I have another question here. Then Mark Wagner wrote in, do natural broadly neutralizing antibodies play a part in this phenomenon, since 25% of people living with HIV produce broadly neutralizing antibodies?
Great question. So if you have untreated HIV for a long time and the virus replicates for a long time, it will train the immune system to develop these broadly neutralizing antibodies. These broadly neutralizing antibodies are weird, okay? They are if you've ever seen a picture of them, they're freaky. Like your typical broadly neutralizing antibody has like this, it's like a hand, right? And then it binds this way. And they grow this like a flower thing. They grow this arm out that reaches into the virus and kills the virus. These things are really, it takes a long time to make them. Now, in a person who makes them, they're making it slowly over time so that the virus has plenty of time to just mutate. So those broadly neutralizing antibodies that we find in people work against every other virus in the world, but have no impact on that person's virus because that person actually has had years to train its immune system to get around it. So I don't know of any good data that the broadly neutralizing antibodies that you get from a person worked in that person, but they work in everyone else.
And Jeff, you had a question. I'm not sure what that in your question is referring to. Was that trying to replicate the Kenyan prostitute cohort?
Oh, for the conversation before about pulse therapy.
Okay.
It was just kind of an add-on. No, my question was earlier on. We were talking about finding these cohorts of post-treatment controllers. Now we've got a horrible natural experiment going on in Africa with millions of people going off therapy, and at some point, hopefully, we'll be able to get them back on. But I'm wondering, would it be feasible to work with African researchers to at least test some of them before they restart to screen for post-treatment controllers?
Yeah, so I was talking. This comes up a fair amount. Should we try to figure a way to learn something from this disaster? And the problem I'm told is that whenever any clinic that lost funding for treatment or for staff also lost funding for viral load monitoring.
Yeah.
And so they don't really have in the cohorts. And if they have limited amount of money, they're not going to spend it on viral load. They're going to spend on getting people in treatment.
Yeah.
So I don't think it's unless someone comes in with a research study.
Well, that's what I was thinking. At a few sites that have that capability to do that. You can't do it on the whole continent, obviously, but
yeah, I think there's some ethical pushback too. If you have that kind of money to measure this stuff, well, shouldn't you just be treating people? So then people are a little uncomfortable. So there's been this debate. So I don't know if we're gonna, but certainly would be, particularly to get hands on this issue of the impact of sex on control. We really need to know that.
Yeah.
Alistair, did you find your question? Do you
Yes, I did.
do you want to ask it?
Can you hear me now?
Yes.
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 Sorry, my Zoom is doing slightly strange things, but I did bring up the chat and thank you, Steve. This has been very interesting and have all sorts of questions, but the one I asked was, with exceedingly low reservoirs, as you specified, is it known if the level is exceedingly low across all reservoir cell types, or might they have significantly low numbers of reservoir cell types, perhaps only a handful rather than lots and lots?
Yeah.
Or is it potentially a combination of the two?
Huh. Yeah. I never thought of that. I'm not aware of anyone actually asking that question very specifically as to whether or not in these low reservoir states, um, there's a shift in the distribution of which cells are infected or not. If you start therapy early, which is basically the best way to get a low reservoir state, you often get relative preservation of HIV in your central memory cells. And so that actually, and those are the cells that are long lived. So that, yeah. So theoretically, now that I think about your question, I bet the answer is sure. That the virus would be more likely in the shorter lived cells in some of these situations. But we don't know. But that's a nice grant. Someone should write that.
Any other
The
questions
other
out
question, if I
there?
may very quickly ask, is as a kid, um, prior to being sexual with anyone,
Right.
I would come home from school feeling miserable. I would spike a fever of 103, 103 and a half overnight. And back then, doctors made house calls and they'd come out and they'd say, yes, he definitely has a fever, 103 plus, it's sort of obvious. But I would basically, the fever would break overnight and I'd wake up in the morning um, in soaked bedclothes. And that happened to me a number of times. And the doctors in Scotland basically said pyrexia of unknown origin. I ended up, from my medical history, seroconverting in early 1976. Didn't get tested till 1993 when my T cells were in the low 200s. Is it possible that something in the pyrexia of unknown origin could have been priming my immune system to make my CD8s more effective that allowed me to be a very slow progressor?
Um, yes. This is that hepatitis C story that we're
Right.
talking about. And I will say that these are theoretical discussions for which there's not a lot of data, but this issue of, chronic infections as an adjuvant to make the immune system work better, has been always been out there. So but you could always argue too that the opposite is true, that these types of infections and these types of persistent inflammatory states would make things accelerate more quickly. You start messing around with the immune system, you can tell almost any story you want. And based on, because 50% of the time it goes in one direction, the other, and it's always a bit of just figuring out that balance. But sure, that's possible.
Steve, could it be that people that have these hepatitis C or the phenomenon that Alistair described, could they be able to control HIV more in the beginning before it gets crazy and out of control? It's not until your body's had enough that your immune system flops out, and so that takes a little bit of time. So
So,
if you have something that's keeping it more
right.
in HIV in control, whatever that is, could that make a difference?
Well, this gets to the issue of the impact of biologic sex and how this is playing out in females versus males. Okay, and so in females, what you have is is that during the acute phase of the infection, early, right? Females mount a much stronger immune response than males. We see this in all infections, like acute COVID, right? Males get sicker than females. And we assume that the evolution is that, females are pregnant, the immune system has to at all costs, short term, protect the mom. That's the way the species survives. But long term, right? that's where you start to see a shift. So the immune system is persistently elevated in females versus males, and then at some point in time, you pay the cost. And that's why you see more chronic inflammation and disease. So like all the autoimmune diseases, like lupus, and things like multiple sclerosis, and even long COVID, more common in women than men by far, like tenfold. And we think it's because of that persistent inflammation burning out the body, resulting in harm. So it's, you know, as you said, Linda, it's with the immune system, right? If you do something good, you pay for it. And it's always figuring out that balance.
Simon, you had your hand up.
Go ahead.
Yes, I did. I just put the question in the chat actually. So ages ago, Steve, I remember talking to you about the difference between, you know, the range of viral reservoir being. I like the slide where you emphasised and showed that the size of viral reservoir doesn't specifically relate to being in primary HIV infection. So you have people who started in chronic infection and their reservoir is really low and often much lower than people who were in chronic infection. And yet cure-related studies still emphasize primary HIV infection as one of the entry criteria. And I think ages ago I was trying to say, why don't we just do a baseline test of reservoir size, which would actually then accurately target the factor that we're looking for, i.e. starting off with a small reservoir, not related to duration when they started out.
We didn't do that back in the day because we had no high throughput way to actually measure the reservoir that people believe.
Yeah.
And now
that'd be interesting now.
Well, now we have fancier measurements, but we're not. I don't know if we're convinced. You know, now we can measure the size of the reservoir, but now we are obsessed about its distribution. Where in DNA is it? Is it in shut down parts of the DNA versus open areas? You know, and then the big problem, Simon, that we
But isn't the interest in shutdown only people like Loreen, which are really, you know, whatever you do, you don't need to do anything with Loreen because she's already, you know, she's in that snapshot area where nothing's going to happen anyway. And there's a Spanish guy that was reported 40 years, and there's a UK case of 40 years now with undetectable viral load. So there will be more people out there as well, I think, that will come forward.
Yeah, you don't need a fancy measurement for Loreen. I mean, because there's like it's like 100,000-fold lower than anyone else. So yeah, you're right. We can find those people if we start doing, but now you need an approved assay, right? To do that, you need something, and then payers have to pay for it. You have to do it in CLIA labs. That's actually the regulatory stuff that prevents us from doing these types of assays in clinical trials. This whole issue of CLIA, it's a mess. But none of the assays that we measure, that we do experimentally, are we allowed to use in clinical trials or even in the clinic.
Okay, interesting. Thank you.
At least in the U.S. I'm not sure about where you live.
Yeah, great. Nice talk as well.
Nina, did you have any? I've seen a lot of comments from you flying by. Did you have any questions you wanted to ask Steve?
While we're waiting, Michael, you had your hand up. Why don't you go?
My question concerns the last gift. I know it's basically right now just Southern California, and unfortunately, I don't know if it's going to advance elsewhere. But I guess, Steve, your point, have you ever been able to do any research with one of these cadavers? And if so, what? And do you think, what is the true value that you, obviously with a cadaver, you know, you can tear apart a brain and things like that you can't do with a living person. But do you think that there is good potential for good outcome that will really apply to cure science and research or anything else that we can really do?
Well, absolutely. A long list of things we can do and is being done, including measuring virus and things like the brain, spleen, and other areas you can't do it. You know, but that team is pushing the envelope and starting to think about giving individuals, you know, complicated interventions that have a lot of toxicity that you can't give to an otherwise healthy person. And that would be extremely transformative. But, you know, we have members from that group. Jeff, did you want to comment?
Yeah, I mean, they're trying to, lots of groups are really interested. There's a cohort in Canada that is doing it. I'm heard there's a cohort in Sao Paulo. In the US, I don't know. I think there was a site at Boston that's interested. So yeah, there's a lot. It's generated a huge amount of interest. But the logistics are just overwhelming. They had to move mountains to find, work with UC Davis to find someone there who could do Loreen's, not a rapid autopsy for Loreen should that time come. So yeah, it's just the logistics are overwhelming, as Sarah and Davey can tell you.
Sarah also said they didn't have the capacity to deal with all these other places as well, right? At the same
Yeah,
time.
they would have to form their own cohorts. They couldn't make
Right,
it a massive.
right.
They're happy to advise them, but yeah, they can't add them to the San Diego cohort. It's all very localized and regional to where it's got to happen because of the logistics. Because you have a team that's on call 24/7.
Mhm. Before
Samuel,
we,
Samuel has his
wait a
hand
minute,
up. Hold
Michael.
on, hold on.
Can you do the survey real quickly?
Yeah, Samuel, you have a question.
Yeah, a quick question. Um, if there are any studies for people who are specifically elite controllers, or if if there is any website or place that we can look to sign up for such thing.
Well, Lorene had that Zephyr website, but she says it's dark. So I don't know of any. I mean, I don't know, Samuel, if you could, I would connect locally for the most part because, the Raygun, Bruce Walker's cohort in Boston, they were flying people from anywhere in the country to Boston. And the NIH was doing the same, but I'm not sure if they're doing that anymore. And so then a lot of these controls, so most academic centers that are like a major HIV center will be studying these groups.
I was thinking too, Steve, Richard is not on the call today, but when we send out the recording, I'll ask Richard for either a link to sites, excuse me, to studies that people are asking about and see if we can add something like that when we send out the link for today's recording.
Noah,
That'd be
you have your
helpful.
hand up.
Yeah, I wanted to ask. So I'm a second year medical student at like Ohio University in Columbus. And thanks for the talk. It's been very interesting so far. I wanted to ask you, like what emerging area of HIV research do you think will most meaningfully change how I practice medicine in the clinic and as a resident in the future?
Uh,
He
probably
sounds
not
like
this.
me.
Probably not anything I've talked about, because we're a long way from having an impact on clinical management, right? I mean, we're in discovery phase, early experimental phase, phase one, proof of concept study. So it's a decade to get across the finish line, at least. Yeah, I mean, I don't know. The big revolution right now is shifting from oral to long acting to ultra long acting. So I think the next big thing in the treatment world will be ultra long acting, which is giving therapy once a year. That I'm not convinced that's going to transform things because I think most of my patients I care for are happy with their one pill once a day. But the companies certainly seem to think it's going to change the world.
Yeah, good to know. I appreciate that. Thank you.
Well, let me just say that your question is so important. And I work with Steve all the time. He's the PI of the DARE Martin Delaney Collaboratory, and he's actually listened to us. I mean, I'm like always screaming about what about the practical stuff? It's nice to look at all of this esoteric stuff that people are interested in, but what about getting practical about how we're going to do this to help people and get there more quickly? So. I mean, he's a convert, he's a true believer in pushing that. And people listen to him because, he's renowned across the world in HIV cure research. So the more people like you say that at every opportunity, how's that really going to help me? What are we doing to that? And, researchers oftentimes are, when you do a study, you have to have tunnel vision about that study or else it doesn't get finished. So we need to make them think in a bigger, broader perspective about, okay, how's this really going to make a difference? So, or is it really practically from where we are now in the research? So thank you. Good luck.
Thank you. I appreciate that.
Michael?
We have no other questions.
Okay. So let's see. We have like 5 more minutes. Anybody have any more questions to pose? Nina, I asked you because I saw a lot of things flying around from you. Did you have anything you wanted to ask Steve?
No, Steve and I actually met at a previous meeting, and he let me know that I didn't look like too many of his outpatients because I am pretty conservative when it comes to my antiretroviral therapy, never having taken a protease or integrase inhibitor, despite living with HIV for 42 years.
Amazing.
Well, maybe you ought to have somebody look at some of these other markers.
I did speak to Mark Connors. I'm sorry, not Mark Connors, but Stephen McGillis after the other webinar, and I'm actually enrolled in the same long-term non-progressor study that Loreen was in, although I'm not a long-term non-progressor. I am a slow progressor, but I have had 20 years of samples stored in the laboratory at Fort Detrick, and I encouraged Dan Rogan and Mark Connors to unearth some of those samples that have been sitting in a federal freezer for 20 years before we don't have access to that anymore.
Nina, to Samuel's earlier question, is Stephen McGillis still enrolling patients if they approach him with their elite controllers?
It's Stephen McGillis's mentee, Dan Rogan, who is the PI on the long-term non-progressor study, and they still are looking for folks to enroll. Let me see if I could just pull it up real quick. And
if you could pop that in the chat and send it to Samuel, that'd be great.
Yeah.
Because that's what he was asking about. Terrific.
We're actually going to have a call in July about the state of HIV cure research, and Richard Jeffries will be leading that, and he will be able to. I mean, he's like an Encyclopedia Britannica. I mean, he's also British, so it's kind of a joke with us. But anyway, he can probably tell you about, just by in his memory, what studies are going on where for a lot of different things. So I know July is a long time away, but in other words, we are thinking about this and how important this is to people. So.
And I did want to mention that Rose McConnell, who's the study coordinator for that NIH study, she was on this call today and had shared it with a few of the other protocol enrolled patients.
So we have 2 more minutes. Let me just
Alistair has his hand up.
All right.
Thank you, Michael. I apologize, Steve, for my Zoom issues. I got about 2/3, I think, of your answer, so I'm hoping to be able to look at the recording afterwards. What I was sort of leading up to was, are you able to look back in the history of the elite and better controllers to see what their CD8 numbers were throughout their medical history, to see if I'm sort of convinced more emotionally than intellectually that I lasted as long as I did before going on meds because my CD8s were through the roof compared to my CD4s.
We never quite figured out. We looked at this a fair amount, and the CD8 numbers, honestly, generally, if they're super high, that was more harmful than good, because of the impact of inflammation on disease, right? So high CD8s, yes, you control your HIV better, maybe, but you're going to have all this other collateral stuff going on. The number, it turns out that the number doesn't say a lot. It's what they do, right? So if you had a lot of HIV-specific CD8 T cells that were potent in controlling your HIV, that's great. But there's no way to know by looking at the number. So with the CD4 count, the number means a lot, but with the CD8 count, the number doesn't mean that much.
So it's time. So let me
Mhm.
just remind you, March 25th, we're going to have the block and lock and gene therapy in-person session. We'll send all this out. And April 21st, the non-human primate webinar as far as education and why we need this and any other questions that people might have. So thank you, Steve. This was great. We really appreciate your time. Now you've done this twice for us. And thank you everybody for hanging out with us and keep them coming back, and hopefully we'll see you again in March and certainly in April. Michael, anything you want to say before we
Nope,
go?
that's all. Thank you very much, everyone.
All righty. Thanks again.
Thanks all.
Session, great questions.
Thank you, Steve.
Everybody.